Undirected graph. Graphs that don't have any direction but an edge or more from one vertex to another. Directed graph. Graphs that have a direction of flow from one vertex to another. Adjacent means having a common vertex and a common side or edges. Matrix. Matrices are rectangular arrays of quantities or expressions in rows and
Adjacency matrices, an array representing if the vertices and edges is adjacent to each other in a graph. It has one row and one column for every vertex. It is one way to present a graph like incidence matrices. The adjacency matrix and incidence matrix are connected because they are presented in one graph. In adjacency matrix, the elements of the matrix indicate whether pairs of vertices are adjacent or not, while in incidence, the elements of the matrix and vertices may be represented as rows, and edges may be represented as columns. It means that the two are connected in the graph because the graph is needed to apply the two matrices, and it just depends on what the matrix will be used for, the graph distribution.
Adjacency matrix, undirected graph. Note: a vertex can't be adjacent to itself. Adjacency is symmetric. As you can see in undirected graph, there's 2 points, point A and point B. And in matrix A, there's 2 by 2. To get matrix A, check the undirected graph. As you can see, A to A is equal to 0 because simply no edge. Then in A to B is 1 because there's one edge to get point A to point B.
This goes the same for the rest of the cell.
Undirected graph with loop. Undirected graph with loop is the same how to solve the matrix in simple undirected graph. Adjacency is equal to 2 if there is a loop from Bi to Bj. Adjacency is equal to 1 if there exists a patch Bi to Vj. Adjacency is equal to 0 otherwise.
To get the degree of a vertex in an undirected graph, sum of the row or the column of the vertex.
So, adjacency matrix directed graph. All edges are directional. One out direction is an adjacency while an indirection is not. Therefore, it can be asymmetric, meaning that there is a one out direction, it means that it's adjacency. And if there is an indirection, it is not considered as an adjacency. So let n be the number of vertices that are assumed to be ordered from v1 to vn, the n by n matrix A, in which 1 if there exists an out direction from vi to vj, or 0 otherwise. So not all connected vertices are adjacent, it depends on the directions. So in this representation, it shows that if it is adjacent, then 1 is written in the matrix, and if it is not adjacent, then 0 is written in the matrix, and so on and so forth.
Directed graph with a loop and the directed graph is also the same. One loop direction or arrow is equal to 1. Adjacency is equal to 1 every loop direction. Adjacency is equal to 1 if there exists an out direction from v1 to vj. Adjacency is equal to 0 otherwise.
To get the degree of a vertex of a directed graph, sum of the row for paths leaving the vertex and sum of the columns for paths entering the vertex. As an IT student, we can use this matrix when we're mapping the framework of our system. We can use this to show the flow and what nodes are connected.